I have turned off most of the lights, so you can see a rectifier tube working. This is a diode tube, and it's been supplied with DC voltage heating only of 4 volts. You can see that here it's actually running on 4.1 AC, but I always supply a bit less of DC, and that's a power supply. So it's been working now for like 15 minutes or so, as I said, without high voltage, because I want this tube to run just with heating in order to burn out that amount of air that eventually went through the glass, because that can happen, and it's a normal process. Glass can let some air through inside, so I want it running like this without high voltage, actually not to be in use and under load. And after a couple of hours working like this, I'm gonna put it into the radio, and we will get high DC voltage. To bring back the light, yep, and we're gonna start testing radio further on. So when we get high voltage, we can move to next part in schematic, and this is over here. But before that, I need to do the same with the E442 tube, so to let it running only with heating. And after that, I will put that tube as well in radio, the same with all other tubes. And we can start examining this point here, and to see if this tube is amplifying high frequencies, actually the frequency that we tune our radio to. I'm still testing this rectifier tube, the diode. It's here now in this box. Maybe you can see a bit of orange glow inside. There it is. It's still running. I'm not sure if I can focus that well. There it is. So it's running pretty much okay. It's being supplied by exactly 4.1 volts. It's looking good, but it's drawing like 0.6 amp, and it should pull like 1 amp. So I guess that this tube is not at good state, but somehow it's gonna work. Maybe not gonna give the best of it, so we will see. I expect maybe some less DC voltage when it's in use, but we will see when I put it back in radio. So far I have measured AC voltage here. That is for power supplying of radio, and it showed 342 volts. Let's say 340 volts. At least 50, 60, maybe 70 volts or even more. This is quite old tube. I mean old in a sense of technology that has been used back then. So maybe even more voltage we're gonna lose on this tube. So it's gonna be 200 and something. 250 is maximum for this tube by specs, of course. And at the moment I'm measuring heating voltage. It's showing 4.65. We know that these tubes are expected to run on 4.1 volts, but that is okay. When I plug in all the tubes, they're gonna pull some electricity, some current, of course, and that's gonna cause a bit of drop in voltage. So that's pretty much okay. Maybe we will get exactly 4.1, 4 volts. That's gonna be okay. For tubes in general, like 5% is okay to go up or down with voltage supply for heating up the tubes. So this looks okay, and I leave this tube to run for a little bit more, and tomorrow I'm gonna put it back in the radio, and I will also double check wiring again. especially this part here, to see that DC is connected correctly, and that's it. Then I move forward, as I already said, with the next tube. It's time now to get high DC voltage in this radio. Tube has been running in total like for an hour with just heating voltage applied, and behaves well. So I have put it back into the socket where it belongs, and I've connected this multimeter. It's on high voltage, a little bit low on battery, but it will work fine. It's connected to this wire here, and at this point over here, after the coil that is suppressing, that is meant to suppress leftovers of AC in rectified current. I have also this oscilloscope that I will use to measure how much of AC is actually going into DC. We can measure that. Like 5% was okay back then, maybe even more, because this is older radio. In 1950s they could tolerate like 5% of AC into DC voltage. So that is producing that hum that you can hear in loudspeaker. My goal is not to improve operation of this radio, just to put it back into operational state as it was when it was produced. So now I will plug it in and I'll monitor the voltage and the tube itself. Heating is working well, but that doesn't mean that it's not gonna spark or something similar when I plug it in. So let's see what's gonna happen, the moment of truth. No, I heard sound that is not correct. Here I had like 300 volts, and now I have to deal with a little sparking sound that I heard somewhere over here. I will check what is that. Maybe it's the switch, maybe some part in radio. Oh, but that is normal. That happens. We will see now what's going on. I will not video this because it's gonna be difficult to make a video and to search for that thing. You could probably not see anything valuable. So when I found the exact spot by turning it on and off for a short period of time, I will show you what is causing this issue. And I found it quite quick. It was less than 20 seconds before I continued to video. This wire, that wire over here, I'm certainly not gonna touch it, is going to the anode of the tube that belongs here. That is E442. I will show you that tube and how that looks like. Why is that wire and not on the pin? Because that wire goes here. That's the anode, and this is where you apply high voltage. Below is heating and grid connections. So that was close to the chassis and it was sparkling. Maybe we can hear it on video. I have not watched the video yet. We have high voltage. Now it's like 325. That seems correct. I'll write down the value on schematics just to have that in my mind. And now I will connect oscilloscope. I will connect oscilloscope now to measure AC, to see how much of alternating current is passing through into our DC. So let's check that out. As we can see, voltage is slowly getting down as tube is heating up. That is okay. These tubes are, all of these tubes used in radio are meant by specifications to have maximum 250 volts on anodes. So it's okay to get around that voltage. And as I said, for the oscilloscope, it is set to measure AC, and this is AC component of our direct current, basically. So you can see that this is a part that has been not annulated. It has 50 Hertz. That is normal, because that is what's coming from the network. My network here, network in Serbia, is at 50 Hertz, and we can see it has like 17 volts of electromotive force, and that is quite high. We are at 285 volts now, and AC is like 18 volts. So close to 10%, if I calculated that right straight from my head now. I'll calculate that more precise later when voltage gets steady. It's right now at 283, and I will see if AC is gonna drop down. But that's basically it. I can definitely expect some hum in audio output, but we are still far away from that. But so far so good. We will see when I plug in next tube. That will be the time to put in some high-F test signal and to trace it down through the radio till the audio output. Now I'm heating up tube AS4100. That is pentode. Originally here there should be E442. And just one correction about the tube, the rectifier tube I've mentioned before. There it is. Actually it was drawing just the right amount of current. I was switched to this tube characteristics, and this tube heater system is pulling 1 amp. Right now I'm supplying 2 volts of 4, and as you can see here it is drawing close to 0.5 amps, which is expected, of course. Now it's running on 2 volts, and I will slowly increase voltage to 4 volts, and as you can see current is of course linearly going up. We are now at 350, 360, 390, there it is, 4 volts. It stays somewhere about 0.7 amps, slowly going up. Okay, I will stay at 4 volts. That's it. Okay, I'm not going to let this tube run for a long time without anode voltage. You might hear that for heating tubes first and then applying high voltage is actually a good thing for a tube. That is so, but there is another effect when you run a tube without anode voltage. There is also a side effect of that, actually negative effect, that is decreasing tube lifespan, especially when you have tubes like this, when heating system is not the cathode, but cathode is indirectly heated, and if you have just heating voltage applied without anode voltage, that results in oxidation of cathode, and usually that is barium oxide formed on the cathode, which is decreasing its emission power, and it's increasing noise, and that's something that we don't want, especially for high frequency tubes. But this is just testing, and I'm running these tubes after who knows how many decades. If this radio was used for like 10 years and then left just to stay somewhere, it could be that this radio hasn't been turned on for like 80 years. So I want to run these tubes without anode voltage for a while, because there are always some micro cracks in glass and very close to the pins. So if there is some air that can burn out, I will let this tube to have some time to do that. But after that, it's going to be put back into normal operation as it was when this radio was produced. So I'll just leave it for like 10, 15, 20 minutes to run like this, and then I will put it back into radio and start high frequency tests. So far so good. It's still on 4 volts. That's okay. I also want to measure temperature for this tube. Let's see what it shows. It's like 40 degrees, 40, 45 at maximum. Just to find that spot. Somewhere here, yeah, here is 46, maybe from the other side. I just want to compare results when I apply high voltage later, when it's back in radio. 48. Let's say it has about 50 degrees. So we will see later when high voltage is applied. Is there going to be any difference? I expect temperature to raise a little bit because it's going to start flowing towards the anode, and that's going to produce some kind of additional heat as well. As you can see, this tube is not transparent, so I cannot see if anode is overheating, but I'll probably get some valuable values when I measure the temperature. But that's something additional. It's totally not important at this moment. It just happened that I have this thermometer, so why not measuring additional stuff if you can. Now I will plug it off, and I'll pull this tube. I'll put this tube back into the radio, and we could start some fun with testing. I have first HF tube plugged in. It's working, and I'm supplying HF signal here. That's basically simulating antenna, and with oscilloscope I'm measuring signal at this point here, so at grid 1 of second HF stage. Why I'm doing this? Because I want to reduce the influence of oscilloscope probe to the oscillating circuit here. If I would measure at this point, I would disturb capacitance and inductance of this coil, and I wouldn't be close to the real frequency that I want to measure. And this is just inductive coupling here, so it's quite convenient to measure at this point actually on this coil here. But well, I have noticed one interesting thing. So here it is. It's working at the moment. I have a lighting bulb in plastic bag just to avoid these pins touching anything from the chases. And if I tune to the highest frequency, and that would be like this, I want to show you something on the oscilloscope. So right now I'm still tuning to the highest frequency without input signal, and there it is. You can see signal now appearing on the oscilloscope. There it is. Capacitors are completely opened, so we are at highest frequency, and as you can see it's measuring like 1.73 megahertz. But this is self-oscillation. This is something that we don't want here. If I change the frequency a little bit down, just watch the oscilloscope how suddenly it's going to disappear, and that's it. It's gone. So we have self-oscillation at the maximum frequency. Something to note. Maybe it will disappear when I have everything put back in place, like this this copper tube, so I will isolate the coils here, and we will see. Maybe something is different. It is causing, maybe something different is causing these self oscillations. But as I said, we will see that later. Right now, I am supplying 890 kilohertz with 0.3 volts at this input over here, and I'm gonna tune a frequency a little bit just to see if I'm gonna catch the resonance. Oh, there was some peak. There it is. That's 1 megahertz and 40 kilohertz. Okay, let's set this to automatic. You can see some intermodulation here. Let's see if I can tune with the radio itself. Yeah, that's it. But it's not pure sine wave. So as I said, everything is open now. I'm gonna check what is causing this interference, and let's just change the frequency. It's gonna measure more precisely when I have more periods. We have also 50 Hertz going into this signal, so it's causing some kind of intermodulation. So this signal is definitely modulated. 50 Hertz signal is added to this. That is maybe even quite normal, considering that poor rectifier, no electrolytic capacitors at a time. So until I heard the signal at the output, I cannot say anything about this so far, precisely actually. So this is it. We have our signal amplified. It's getting at this point definitely amplified, and without this tube it wouldn't appear here. That's for sure. So next step is to add the second tube, and that is where things are gonna become a little bit more tricky, because we need to tune those circuits. We have self oscillation here, which needs to be, because this is I believe a Radione, and it can get into self oscillating if it's not tuned well. But just before starting to self oscillate, that will be the point where our receiver is the most sensitive. So this is where reception is going to be the best. So that's going to be interesting now when I plug in a second tube. Now everything is back in place. All tubes are placed back in radio, and it seems that this radio might be just a super regenerative type. I'm not sure. It has oscillations, and it has some ultrasonic interruptions in those oscillations. That is typical for super regenerative receivers. We'll see. Still to be investigated, but just because of that, most likely I'll have to add audio monitoring of a kind. I'll see. Maybe using earphones for the start, and that's just gonna be interesting. You cannot just plug in audio amplifier directly on audio output here. This is audio output. It's labeled with the L and S letters. I can show you that here. There it is, L and S. And on other type of schematic, basically for the same radio, you also have here loudspeaker, or basically just for the earphones. But pay attention how sound is obtained at the output. This is low frequency audio frequency transformer. Here we have audio output, maybe even a little bit amplified by this transformer. Maybe not sure what ratio this transformer has, and signal is supplied to grid 1, and then it's being amplified. But take a look at direct current power supply for anode. It goes here, and it cannot go through capacitor to the anode. So when you plug in earphones, those earphones need to be of high resistance, typically like 2 kilo ohms, and then DC will go here through your earphones and back on the anode of B443 tube. What it means? That means that high voltage is going directly through your earphones. It's obvious why that was abandoned, why it's not safe at least. So let's see. When I touch this pin, we have like 55 volts. That is probably the anode. I still didn't check that on the radio itself below to see what is the wiring, but most likely it's the anode, because when I touch here I have 140 volts. 140 volts directly on this pin that can easily be touched by hand, so you're gonna be shocked if that happens. It's DC, low current, so you probably won't get hurt seriously, but definitely not gonna be pleasant thing. And the other thing I don't like is that 150 volts is going directly on your head through the earphones. So imagine if earphones wiring is bad or something. So not good, but this is how these radios work. So I will attach here 2 kilo ohm, 2.2 kilo ohm resistor here, and then on these pins, I just gonna connect it in parallel, and this is where I gonna take audio output, but just to show it on oscilloscope to see what I gonna get here. And it's gonna be interesting to amplify that, of course, through some capacitors, maybe even splitting transformer to isolate DC from this part. We will see, but anyway, for the beginning maybe I'll use earphones to see how that works. But first I'm gonna check how it works when I set this resistor, because I don't want to put my earphones as a test directly, so there is always a chance that you destroy them. To destroy one resistor, it's not a big deal. At this point I'm measuring voltage over the resistor that is connected where earphones should be, and this is over here, so it's showing 8.2 volts, 8 volts let's say, and resistance is 2000 ohms, so that's like 4 milliamps of current running through this resistor. So that's gonna be quite fine for these earphones. These are also quite old, and they're like, let's check, yeah, they're also exactly 2000 ohms. So now I will turn off the radio, because as we saw we have 150 volts over here, and I'll connect these earphones and hopefully hear something that that's gonna give me some hope that it's not gonna be very hard to repair it. It wasn't quite hard to make it working again. It's not in perfect shape. There are some fine tunes that needs to be made, but you can probably hear sound coming from the earphones. I'll get them closer to the camera so that you could hear. Now what you hear is 800 Hertz tone that is coming with the amplitude modulation. Let's see where that is. Frequency is 900 kilohertz. That is the frequency that I have tuned this radio to. And channel 2 is source of modulating signal, which is set to 400 Hertz, I think. I can check that now when I switch to, yeah, it was 400, sorry. So you see now that signal has gone from the radio. the signal generator is connected here to antenna. It's now tuned to 900 kilohertz. If I move the dial a little bit left or right, you can hear oscillations. This is all coming from positive feedback. I need to check if this needs to be tuned a little bit, but if I switch off the signal generator, you see it comes back into self-oscillating state. Now it's back again completely silent, because what it receives now, it's only unmodulated 900 kilohertz signal without a modulation of any kind. So if I switch back, I'll tune it to 800 hertz. Okay, or let's say kilohertz. Now it's 1 kilohertz. And when I switch to amplitude modulation, you can hear it now with the higher frequency. Let's try 1.5 kilohertz, for example. I didn't try that yet, to see how we can hear that signal. That is fine. Just wondering if it can go to 3 kilohertz, for example. Let's try 3.5. Quite high. So just for basic voice usage, you cannot expect some high frequencies in this radio. I'm talking about audio, of course. Let's get back to 800 hertz. Modulating, this is it. Now I can fine-tune it. There it is. Here's the capacitor for regulating feedback. Doesn't have much effect now, because signal is quite strong. I can reduce amplitude. At the moment is 0.07 volts. Let's see if I need to tune it with 0.1. No. Definitely I need higher voltage. 0.03 volts. And it can be tuned nicely, and you see that feedback is reacting actually. It's quite normal to hear some hum, because this radio does not use electrolytic capacitors, and this is quite nice sound regarding its construction. Also, what change I had to make is that I have noticed that this anode is not connected to high voltage. Actually, this resistor was not connected to high voltage, and it was misconfigured. Someone soldered that wire to another pin. I just rewired it again, and it wasn't working. Now when I have changed that, it's working back again. So quite easy fix, easy regarding that. I didn't have to change some parts and so on. Some capacitors have been changed. Now I will see what I can do with inner parts, maybe to rewire something and so on. I'll definitely want to change this capacitor. It is the one over here connected to high voltage, something that definitely needs to be replaced. I cannot rely on this capacitor. It's close to 100 years old, so definitely need a new one. So what can I say? I'm quite happy that I have it working. One mistake I made a presumption, not analyzing this schematic very well, that it was super regenerative receiver. It's just regenerative receiver with the high frequency amplification. Actually, we have a part here that is splitting oscillating part from the antenna, so this way we're reducing emitting its own oscillations back into the air, which would affect other radios. So amplification and that splitting is actually part of this tube here. Then we have part with positive feedback here, which is increasing sensitivity and amplification of the radio itself, and then demodulation and local not local frequencies, low frequencies for our earphones, and it's been amplified in B443. One interesting thing is that I will show you with these earphones. This tube, audio tube B443, is actually getting high voltage through the earphones. So take a look at this high voltage wire. This is where we have like 150 volts approximately. It's going here. Here it's capacitor. It does not conduct DC, so it needs to go through the earphones, then to the anode of this tube. So this is one pin for the earphones. This is another pin. And if you were wondering about audio regulation, there is none. This is how you hear it. There is no volume tuning. Now I will measure voltage at this part here. This is where power supply goes for the earphones. It is this pin here. So let's measure the voltage. 130 volts. So, as you can see, touch this pin and press your finger at the same time to the chassis, and you're gonna have some fun time. Okay, that's pretty much it. If there's gonna be something more interesting about this radio, I'll video that as well. Now I will deal with what I said previously and with the chassis of this radio. Another thing is, I think, hopefully solved, and that is this capacitor that is used to regulate the amount of feedback. This capacitor is over here, and it was not connected. Let's say by default, it was not connected correctly the way it was when I got this radio. This part I will show you. That part was connected directly to this wire here. It was not actually this. This capacitor was connected to another wire here, not there. So this is what I switched, but at the moment I'm not measuring that. I'm still using my signal generator, supplying high frequency here, unmodulated, just a carrier wave, goes to grid 1 to AS4100. Original E442 is not present, so that's the way I got the radio with this tube. So only this tube is working now. Other two tubes I have removed. What I noticed is that this capacitor actually has no effect in receiving signal. You can tune it the way you want, nothing happens with received signal. And when I separated electrically capacitors, this whole plate from the chassis, basically to put it the way it is when radio is assembled, I got oscillations all the time. It was receiving signal, but with some other oscillations all the time. So that is definitely not good. So what I decided now is to get back to square one and to test step by step each stage in this radio. So at the moment I'm testing if AS4100 is amplifying signal. Signal is connected here to the input into the antenna. At the moment I'm supplying frequency of 570 kilohertz, somewhere at the beginning of a band, medium wave band for this radio, and it's a sine wave of amplitude of 0.1 volt. What you see here is signal that is getting out of first amplifying stage. Actually, oscilloscope is connecting here directly to the anode of first amplifying tube, and I will tune the radio so you can see how the signal behaves. So we know this definitely works. Now it's not in resonance. When I tune the radio to the resonance, to the signal, basically this is it. This is the highest amplitude we have here. Quite nice oscillations, so that works well. We can see some statistics here on oscilloscope. Of course it's varying a little bit, but that's normal for digital instruments. Here we see a frequency of roughly 570 kilohertz. That is okay. And measuring amplitude, I can also measure what is the amplification of this first stage. If I first measure signal on grid 1 and measure amplitude at the output, and I can see what is amplification of first stage. But basically what I'm interested in now is to see if this stage is working. That is just fine. So now I will plug in another tube, E438. That tube is getting here, and next thing that I will check is what I get to grid 1 and if that signal is also amplified here. So that is the next step. Now we are at second part, and this all looks okay. So E438 tube is plugged in without B443, actually B409, which is in the tube, in the radio, sorry, and that is working fine. So I will show you now how that looks. I didn't change pretty much anything. At the amplitude of 0.3 volts I get signal like this, and this is tuned to the maximum amplitude, actually to the resonant frequency. It's distorted. You can see like a triangle. We expect sine wave. This is because that input signal is too high, so it's being distorted in radio. So I will go down with the amplitude until I see nice sine wave. Oh, I went too much. Okay, we can say that this is okay. This is nice sine wave, Let's see if I can get better view. This is it. Yeah, that is okay. And now we are at 0.03 volts. So this works as expected. I can easily tune to the resonant frequency, and you can see here that goes well. Now I will check how the signal looks with modulation, AM signal basically, and if that goes well, I will plug in B409 tube for demodulation and for audio amplification, and we will see. What we'll get to at the output. So far, this is all fine, and based on that, of course, I expect modulated signal to go well through this radio.